Hello YouTube, this is UMails03. In the previous video, we took a look more at the exec function and at iterators, but the new topic that we brought up is called matrices, and we essentially classified a matrix as being a list or tuple of lists or tuples, where each of those inner or individual lists or tuples has ints or floats in it. So we're talking about a rectangular grid of ints or floats, like a rectangular matrix of numbers. So hopefully you're familiar with this concept from a mathematics class that you might have taken in the recent past. But what we're going to do is also review running a module as a script in this video, and also the iter function, the exec function, and then we're also going to talk about the eval function, and also some other things that you can do with matrices. So recall that if all of your code is embedded in functions, then you can go ahead and run your module as a script, and you can run your Python file starting from this line right here. So we say if underscore underscore name underscore underscore equals double quotes underscore underscore main underscore underscore double quotes colon, then this is a line of code that would enable your program to start at this particular place. So we would just start up at line 115. So hopefully that's clear to you how that works, right? And we could say frozen set equals, and then we're just going to call it frozen set, right? Equals frozen set of, and then we pass in a list. So remember, frozen set is created by passing in a particular iterable. So here we pass in a list, and returned is going to be a set with only unique elements that is immutable, so it cannot be modified. We talked about frozen sets, but it would have the elements 5, 3, applesauce, and false, because those are the 4 unique elements in this list. And then we could say frozen iter equals iter of frozen set, and then we could say a equals 0, while a is less than length of frozen set, print next to frozen iter. So we said basically you say iter of a particular iterable, and it creates what's called an iterator. So here on line 116, we're setting frozen iter to be assigned to an iterator on the frozen set, right? And then we're going to say, well, a is less than length of frozen set, because we want to know how many times to call next, and we only want to call next however many unique elements that were in the frozen set, because in the previous video we saw that we got an error, we got an exception if we called next too many times. Like if we called next of next on an iterator, but there were no more elements left. So we could say, well, a is less than length of frozen set, print next to frozen iter. And then we could say exec of a equals a plus 1. And here, what we're passing into the exec function is in double quotes, right? And we talked about how if you put basically a string into the exec function, then it executes that Python code. So it would just increment the value of a by 1, and we would only go ahead and print next of frozen iter however many unique elements there are in the frozen set. So hopefully that's clear to you, and we can go ahead and run this. I think I was producing a runtime exception with something I was doing earlier. So let's just go ahead and run this file again and think about the output that we get here. So we go ahead and get false, 3, applesauce, and 5. And then it says exec of print, let's print a sum matrix. And here we have another example about how if we try to do an exec, but then we try to basically print a string or something like that, but we need basically double quotes or single quotes in the context of our Python code, then in order to put that into the exec command, we'll probably have to use an escape sequence. So here you need double quotes, you need a backslash in front of your double quotes to let Python know that that's actually just a double quotes, right? That would be an argument inside of this print function. But you wouldn't want to go ahead and end the double quotes that started the exec function, right? Because you want the exec string to not end until like the end of the line, basically. So hopefully that's clear to you, but that's why we need an escape sequence. And we were talking about these techniques for matrices. So we have a class called arrays, and so that's defined on line 4, and then we have static methods, right? So we said that static methods have this @static method decorator, and you call them on the class itself rather than an instance of the class. And so sum matrix of matrix 1 comma matrix 2. So this returns the sum of 2 matrices defined by a list or tuple of lists or tuples, where each corresponding list or tuple must have the same length and the ultimate elements or numbers. Or if you wanted to concatenate strings together, presumably this sum matrix method would allow you to do that as well. You could say A plus B for 2 strings, A and B, and it would just go ahead and concatenate them together. We're already very familiar with that. And then we would have a formal doc string here. So we just have two parameters, two matrices to add together, and it returns the sum. And so result is equal to an empty list. And then we say for k and range of length of matrix 1, new row is equal to the empty list. And then for w and range of length of matrix 1 of 0, new row dot append of matrix 1 of kw plus matrix 2 of kw, and then result dot append of new row. And we would just go ahead and have a for loop inside of another for loop, because the inner for loop would iterate through the elements in each of the rows, and then the outer for loop would iterate through each of the rows in the two-dimensional list or tuple, right, in the matrix, and then you would just return the result. And so this is a very clean sum matrix method, and it practices the fundamentals of writing doc strings that we've talked about previously. And then we also have a difference matrix method, right? And we talked about this in the previous video, but it's very, very similar. And the only adjustment that we have to make in order to get from the sum matrix method to the difference matrix method is to go ahead and replace the plus sign on line 22 with a minus sign on line 43. And that's the only adjustment that we make, except for, maybe adjusting the doc string and calling it difference matrix instead of sum matrix. But the result is essentially the same. You just say minus, right? You just subtract the second element from the first element. They're like the corresponding element in the second matrix from the corresponding element in the first matrix, rather than adding them together, which is what we did in the previous method, right? And then we could say define minimum entry of matrix. So how do we find the minimum element in a particular matrix? So we could say min values equals the empty list, and then we could say for k in matrix, min values dot append of min of k. So that would basically add the minimum element from each of the rows. And then we would go ahead and have to go ahead and return the minimum among those minima, right? Because in a particular row, you could find the smallest element in that row, but that might not be the smallest element in the matrix as a whole, right? That might only be the smallest element in that row, and then maybe in a different row you have a larger element. And then we could have something similar for the maximum entry function. So you could go ahead on your own and fill out these doc strings, right, in order to be the most successful software engineer you could. But we could say add static method, so we need another decorator, and then we just define maximum entry of matrix. And then we could say max values equals empty list. For k in matrix, max values dot append of max of k. Return max of max values. Hopefully that's clear to you, and that's making use of the min and max numeric functions that we talked about in lesson 24 and reviewed in the previous video. And then we can also, I think in the previous video, we ran out of time to talk about 4 more static methods that I want to talk about in this video, but they're very quick. But basically, we could think about a matrix as being a rectangular grid, right? And we could think about the elements or the numbers that occupy the top left corner, or the top right corner, or the bottom left corner, or the bottom right corner. And what we need to do is think about the first index position. So we say matrix, and then we have one index position, like in the first pair of square brackets, that's going to be the particular row. So that's going to be sort of our vertical component. It's going to be what row do we go to? And then the second index position is within that row, within row 0, what column should we go to? And here it says, well, we're just going to be at column 0, right? So presumably this would be the top left element in the matrix, right? If you were thinking about counting from the top left, right? You have to pick a convention. You have to pick a starting point and a starting direction. But after you do that, you could figure that the top right element exists at matrix of 0, length of matrix of 0 minus 1, right? So these would be the coordinates of the top right element in a particular matrix that you pass in to this static method, right? And then you could also have the bottom left would be matrix of, and then the first coordinate, the row coordinate, would be length of matrix minus 1, because it would be the bottom row. But since it would be the leftmost column, the second index position would just be a 0. And then for bottom right, you would return matrix of length of matrix minus 1, length of matrix of 0 minus 1. So hopefully that's clear to you. And then you could also return the number of entries in the matrix. There's a simple function that accepts a matrix and returns a number. It returns an int, which represents the number of elements, the number of entries in the matrix. And presumably that would just be equal to the number of rows multiplied by the number of columns. So we could return length of matrix 1 times length of matrix 1 of 0. And then one more, we could think about a transpose method. So essentially what a transpose does is the transpose of a matrix essentially flips the rows and columns. So if you have a matrix, if you have like 1, 3, 6 in the first tuple, and then 7, 5, 3 in the second tuple, well then you would have like 1, 7, and then I can't remember what I said, but you would have to go ahead and flip it, right? Like if you had 1 and 4 in the first row and then 5 and 6 in the second, then you would flip it to be 1 and 5 in the first row and 4 and 6 in the second row. But the point is that you would go ahead and flip the rows and columns, right? And so your first row vector would just be the combination of all the elements that were in the first column vector, right? And then your second row vector in your transpose is going to be all the elements that were in your second column vector in the original matrix that you passed in. But this is an example of a class method, right? And so we said with class methods, they're different from static methods because the first thing in the parentheses is usually like CLS, but you can call it whatever you want. Here it says C, and we get a Python enhancement proposal. If we hover over it, it says usually the first parameter of such methods is named CLS, right? And you could choose whether or not you're going to let that bother you, but then the PEP suggestion goes away. But this is a class method. It's very similar. You still call it on the arrays class, but you just pass in this CLS thing now, okay? And then also class methods require a class method decorator rather than a static method decorator. Okay, but if you don't have a decorator on top of one of these functions, then presumably it's an instance method, right? But class methods and static methods are similar, as we talked about in a previous video, like lesson 39 or 40, because they're called on the class rather than an instance of the class, and also because they can basically do the same things. Like we talked about how you could have used either a class method or a static method to create an instance of the person class, and we said it's called a factory method when you have a static method or a class method that works the same way as your constructor. But anyway, we're going to say for this transpose, how does the transpose work? So we say result is equal to an empty list, A equals 0. Well, A is less than length of matrix 1 of 0, new row equals empty list, B equals 0, while B is less than length of matrix 1, new row dot append of matrix 1 of BA, B plus equals 1, result dot append of new row, A plus equals 1, return result. So hopefully after 64 lessons, you're comfortable following along with the logic, and you could go ahead and make hashtags 2 spaces after each of these lines and remind yourself about what each of these lines of code does, right? What does each of these lines of code actually do? But the point is that this would return a matrix where you feed in a matrix and it returns the transpose, or returns another matrix where all the rows and columns are essentially swapped, like everything is sort of rotated a little bit. So hopefully that's clear to you. But we're going to say if name equals main, right? And then we created this frozen set, and then we iterated through it. So we said iter of frozen set, and then we called next on the particular iterator. So that's another review about how to use iterators in Python. It's another big topic in Java as well, if you are following my Java playlist. And then you could say exec of print of let's print a sum matrix. This is where we left off like 10 minutes ago, right? And so we're going to say we're going to create 2 matrices, 2 two-dimensional matrices. And so we have 4, 2, and then int of input. And so in order to execute this code, we actually have to feed in a number. So I'm just going to feed in 100. Hopefully you can see that down here. I could actually make this slightly bigger probably. But anyway, I could just go ahead and print 100, right? And then there's a lot more stuff that gets printed. But the point is that the element in the third position of the first row of this matrix A is 100 because that's what we assigned it to, right? And then matrix B is going to be this first row, this first list, and then this second list, right? And then we're going to say for f in arrays.sum matrix of matrix A, matrix B, print of f. And so we're going to go ahead and print the sum. So what's 4 plus 3? It's 7. What's 2 plus 0? It's 2. What's 100 plus 7? It's 107. What's 9 plus 9? It's 18, right? What's 10 plus 4? It's 14. But the point is that we're adding all the corresponding elements together. Hopefully you can follow that logic. And then we could say print and the subtraction matrix. print f for f in arrays.difference matrix of matrix A comma matrix B. So this is an example, as we talked about in a previous video, of a list comprehension, right? And so we could actually, this will be, I guess, a generator object, right? So we could go ahead and put this into a list, right? So now we could turn this into a list comprehension, and we could go ahead and stop and rerun it. I think it was waiting for another input. So anyway, we can go ahead and run this and we get the subtraction matrix. So sometimes we have to fix bugs when we write code, but anyway, 4 minus 3 is 1, 2 minus 0 is 2, 100 minus 7 is 93. But the point is that the difference of each of the elements gets lined up, right? What's 11 minus 5? It's 6. What's 5 minus 20? It's negative 15. And then we could find the minimum entry of the first matrix. That would be string of arrays.minimum entry of matrix A. We have to convert it to a string because this minimum entry would presumably return an interfloat. And then maximum entry of the second matrix would be 20, but we say arrays.maximum entry of matrix B. So that's calling a static method, right? And then my string equals total number of numbers between the two matrices. Print of my string plus concatenated with string of arrays.number of entries of matrix A plus arrays.number of entries of matrix B. And we get 16 because 8 plus 8 is 16. And then the top left element in the second matrix, we saw that that was a 3, right? If we scroll up, that would be a 3. And then the transpose of the first matrix would be 4. Would be what? So 4, 6, right? And then we would have 2, 10, and then we would have 100, 11, and then we would have 9, 5. So the rows and columns are getting swapped. So hopefully that's clear to you. And then we could say, what else could we do? So the only other thing I want to talk about in this video is called the eval function. So we've already talked about the exec function, and we said exec of x. It would basically accept some string x and execute it as though it were Python code. So like x is a string, it's in double quotes, and then you'd pretend that the double quotes in the exec function aren't there, and then literally you could just execute that like Python code. There's another function in Python called eval. So eval of x, it accepts one input. So what we're going to do is we're going to understand that if we have eval, so if we say eval of x is equivalent to the variable or value represented by x. And so basically what it does is it accepts a string, and it basically returns the value that would be existing there without having the string, essentially. So it sort of undoes a string and just gives you the value of the variable or the expression inside of the quotes. So let's do an example. So we say cookie equals 52. We just assign an int variable to 52, and we say print eval of cookie, but we're going to have cookie as a string. So you can see these are in single quotes, but you could do it in double quotes too. But the point is that you would just get, essentially print eval of cookie, right? So essentially what is going to happen here? So we could do eval of cookie, right? And then we could do times 2. So we could do cookie times 2. It would say cookie equals 52. And then what if we say print eval of cookie times 2? So this is a little bit confusing, right? So essentially what it does is if you undo the double quotes here and you just think of printing cookie times 2, it would print 52 times 2, which is 104. And we could do the same thing by essentially concatenating two strings together. So what if we say print eval of, and then we have one string with 10, and then concatenate it with another string which has the multiplication sign with cookie. But if you sort of undo everything in the string from the string, you just evaluate 10 times the value of the cookie variable. So 10 times 52 is 520, and that's why that's the next thing that's printed on the console. What if you say print eval of cookie times 2? Well, here, if we have cookie, here we have an escape sequence where we have a backslash in front of two double quotes. And this is another example of this, but this would print the string literal, COOKIE. And we said that it would do a multiple concatenation. Like if we multiply a string by an int, it just repeats that string that many times. So we just say cookie, cookie. But the point is that since we have this escape sequence, we're actually going to treat cookie as a string, even though we're already inside of eval, which is treating an expression or true variable as a string. So hopefully that's clear to you. But then two more examples. So print eval of float of input of enter a float, please. And then we could say 16.2. And then essentially if we say print exec of eval of 2 plus 1, what would that do? So eval of 2 plus 1, well, that would just be eval of 3, like the actual number 3. And so then exec of 3 would basically go ahead and print. What would that print? So then that would just print 68.2. So that would just print the value of those two variables. So hopefully that's clear to you, and we'll review more of that in the next video. From me, Melso3, thanks for watching, and please subscribe.